Hi there! Welcome to this series of videos that have the aim to make you learn about 3D visualization tools and real-time simulation for which ROS is extensively used. Before diving into it, make sure to subscribe to the channel and give a thumbs up if you like this video and if you got a lot of technical value out of this. First of all, why do we need to simulate a robotic application? Well, as I have explained already to you, robotics is a complex field. It deals with computer science, mechanical and electrical hardware. You might already know that most often you haven't available hardware to exploit for developing a manufacturing application in general. Before spending money in design and producing the mechanical and electrical hardware, it is always a best practice to simulate the whole process, algorithm and ROS packages in a virtual world, with real physics applied in order to replicate as much as possible what will be the process once that the hardware has been deployed. So, if we want to make this simulation, we need a software that simulates the real physics of a real world. And for this purpose we are going to use Gazebo. Gazebo is a physics-based, high-fidelity 3D simulator for robotics. Gazebo provides the ability to accurately simulate one or more robots in complex indoor and outdoor environments filled with static and dynamic objects, realistic lighting, and programmable interaction with ROS. ROS has its own visualization tool that is called RViz, that stands for ROS visualization. But this tool doesn't tell you anything about the physics applied in the real world. You don't have the gravity applied on your environment. RViz is used for visualization the robot's property, such as the shape of a robot, the joints angle, path planning, trajectory, camera interaction, and so on and so forth. We will need something to let ROS communicate with Gazebo. And for this we are going to use some packages that allows ROS to interact in the real time with the 3D physics software Gazebo. These tools are like plugins, URDF files, that stands for United Robotics Description Format, and other packages. Don't worry about this terminology, you will discover these tools and you will learn everything you need to make this connection in the upcoming videos. If you remember, in the setting up section I have suggested to you to install the desktop full version and make sure to have installed the full desktop version in ROS. Before opening Gazebo, I want to point out to you the main components of Gazebo. The first main component involved in running an instance of a Gazebo simulation is the gzserver, or also known by gzserver. Gzserver performs most of the heavy lifting for Gazebo. It is responsible for parsing the description files related to the scene we are trying to simulate, as well as the object within. It then simulates the complete scene using a physics and sensor engine. The second main component involved in running an instance of a Gazebo simulation is the Gazebo client, or also known by gzclient. Gzclient, on the other hand, provides a very essential graphical client that connects to the gzserver and renders the simulation scene along with useful interaction tools. While you can technically run gzclient by itself using the following command: gzclient. It is common practice to run gzserver first, followed by gzclient, allowing some time to initialize the simulation scene, object within, and associated parameters before rendering it. To make our life easier, there is a single intuitive command that necessarily launches both the components sequentially, and it is Gazebo. If you are facing some problems in saving the world, it is better to run Gazebo as an administration user. So you can type from the terminal sudo then Gazebo. You will simulate your application environment thanks to what it is called a world. A world file in Gazebo contains all the elements in the simulated environment. These elements are your robot model, meaning 3D objects that you can design with a graphical tool like SolidWorks that you can import, for example, its environments, lighting, sensors, and other objects. You have the ability to save your simulation to a Word file that usually has a Word extension. To launch the simulation from a Word file, you just need to type Gazebo, the name of your Word, .word. The Word file is formatted using the Simulation Description Format, or SDF for short. Here's a basic format of an SDF Word file. For simplification, you must create a separate SDF file of your robot with exactly the same format as your Word file. This model file should only represent a single model, for example, a robot, and can be imported by your Word file. The reason why you need to keep your model in a separate file is to use it in other projects. To include a model file of a robot or any other model inside your Word file, you can add the following code to the Word SDF file. So you just need to put the tag include, then inside of it you can put the tag URI and then the model. To interact with a Word, model or sensor in Gazebo, you can write plugins. These plugins can be either loaded from the command line or added to your SDF Word file. So, as a recap, Gazebo reads Word files that have the extension of .word. These files is written in a language called SDF that is similar to XML. This Word file describes everything you need to simulate your physical environment, like the lights, the gravity applied, the scene in general. You can design your robot or a general 3D object and save it as a model. Then you can convert this model into a SDF file. So your Word file and your model file can talk to each other, and you can easily use this model everywhere in other Word project by including it. That's all for today. I hope that now you have a good understanding of what Gazebo is and why it is very useful and why it is important to use it. You should have a good understanding of what a Word file is, an SDF file, as well as the model files, and the ability that you will have to load those in everywhere you want in your packages. If you like this video, don't forget to subscribe to the channel and put a thumbs up in order to do not miss the following topic. Thank you for your attention and keep learning robotics with Ross.